have these things actually. So you need to define, okay, what is input format, what is output format, what is JVM configuration, all these things you need to define. Then only it will work. Otherwise, okay, if you don't define all these things, okay, it will take the default ones. Clear? Clear? Or any question? Okay. So then, okay.
How, if two reducers are used here, how
Uh,
reducers will decide that one reducer will take IT, another reducer will take that other department?
Good question,
How
sir.
they will decide?
Okay. So let us understand this map reduce pipeline actually. Okay. This is your input file. This is your input file. Normally, when I say input file, your input file will be divided into blocks. Correct or not? Okay. This is your input file. Okay. This is your input file, employee.csv, which is stored on HDFS, and okay, that is divided into blocks. This we know. We all know. Okay. Now, okay, what is input format? Input format is a so this is the input format. Input format is something like, okay, the information, okay, like, okay, how to read and process the input, how to read and process the input actually. Mhm. So as part of input format, okay, you need to tell, hey, this is my row separator, this is my column separator, this is column for key, this is okay, what are the required keys, what is the column for value, all this information, okay, you need to provide. Okay. And one more thing is, okay, suppose, okay, if you're storing your data, okay, will you store like, okay, half of the file will be comma separated file, half of the file will be tab separated? So you have a file. Okay, normally if you have a file, okay, it's a CSV file, all the whatever data you have, okay, in this file, okay, everything, okay, will be in the comma separated only. Will you agree with me?
Yes,
Will
sir.
you agree with me, guys? Okay.
Yes, sir, yes.
But okay, it is not like, okay, half of the data will be comma separated, half of the data will be tab separated. No, normally it will be. So if it is tab separated, entire file will be tab separated. If it is comma separated, entire file will be comma separated. Okay. So that is the reason, okay, input format is common for all the blocks. Okay, all the blocks. Okay. So now with this input format commands, okay, what it will do, what Hadoop will do, or what YAML framework will do, it will try to convert the blocks into input splits. Understand? It will try to convert the block into splits. Okay. So this is called now using input format. Okay, they're converting the blocks into splits. Okay. Think that I have split 1, split 2, and split 3. Okay. So on top of split 1, what is happening? Okay, so we have two splits, so two mappers will run. It means two containers are required to process this job. Okay. Now the next thing, okay, on each split, okay, the first class is record reader class. Okay. What record reader will do? It will read record by record. Okay, so from each split, it will read first record. Okay, so it will read the first record and give it to the, okay, so read the record from each split, okay, and give it to the mapper. Okay, so for mapper, okay, what is the input? Okay, each record. So here, okay, record reader will read each record from here and give it to the mapper. Okay, so what mapper will do? So for mapper, input is each record, record 1, record 2, record 3. Okay, and output is, okay, based on the record 1. Okay, it will generate the output. Okay, with the record 1, okay, our required, okay, based on input format, okay, our required keys are IT and HR. IT and HR. Okay. So now IT, okay, so it will take, okay, each record from record reader and check, okay, whether it is IT or not. If it is IT, it will just push the details to output, mapper output. Okay. So it will collect only the IT and HR records here. Here also it is the same thing for IT and HR records. Okay. Now mapper work is completed. Okay. Now there is something called, okay, partitioner. What partitioner will do? Okay. So here, okay, IT came 3 times, HR came 3 times. Okay. So IT, okay, it is putting like this: 10,000, 20,000, 20,000. HR, okay, 10,000, 10,000, like this actually. Okay, like this it is putting. Okay. Ark, if you want to add, okay, one more line also, you can add it here. Okay, let's say this is my data. Okay. Okay. So these are the two blocks. Okay, so based on this, okay, so now you got this is split 1 and split 2. So here, but here you will get okay, IT 30,000. So here, okay, so 2 times IT came in this split. Okay, in this split, okay, 3 times IT came. Okay, 1 time HR came, get 2 times HR came. Okay, so now IT 20,000 comma 30,000. 20,000 comma 30,000.
So partitioner is part of a mapper
So
only.
exactly, see, okay, if you see here, okay, okay, this entire part is called. I mean, this entire part will be done inside the mapper. Understood? See, these are the different steps. Okay, we have inside the mapper. Understood? When I say mapper, inside mapper you will have input split, record reader, mapper, and partitioner. All these things. Okay? Understood? Sir, okay, I'm saying map reduce. Okay, so what is mapper here? This is the mapper part, this is the reducer part. Okay, so each mapper will have same steps. Okay, each reducer will have same steps. Clear? Are any questions? Okay, if no answer, okay, I cannot do anything else. Okay, you should open your mouth and tell me whether you understood or
Sir,
not.
how it will divide the two items here, HR and IT? Is there any divide rule is there in this?
Right? Sorry?
IT and HR, it will be divided right here.
Very simple, sir. Okay. First of all, what partitioner will do? Partitioner will okay, take these individual records and combine them into key value list. See here, okay, how is my output here from mapper? Key value, key value, key value. Okay. Now I'm combining that into key value pairs. Okay, key, these are the value pairs. Key value pair. Okay, till this you understood, right? Till this you understood, right? Okay. So now partitioner knows that, okay, so it has two things actually. Okay, two keys, IT, HR. Even this partitioner also know that, okay, it has IT and HR. Okay. So now, okay, what will happen? Now, if you use single reducer, what will happen? Okay, if you use single reducer, partitioner one output and partitioner two output, okay, both will go to the same reducer. If you use single reducer, partitioner one output and partitioner two outputs both will go to the same reducer. And okay, so that reducer input is this one and output will be like IT. Okay, so IT, two ITs are there. Okay, it will take this one plus this one. Okay, total 1 lakh. Okay, and HR it will take this one and this one. Okay, so
Yeah.
it will give you 30,000. Okay, so if it is single reducer, there is no confusion like, okay, IT should go to which reducer and okay, HR should go to which reducer. Correct or not?
Yes, yes. There is no confusion here.
No confusion at all. Okay, but what in case if you have two reducers? What in case if you have two reducers? Okay, if you have two reducers, okay, if you have two reducers, who will decide that? Okay, who will decide that? Okay,
First reducer will be go to IT.
first
How
reducer
will
should take IT and second reducer should take HR. This guy will decide.
partitioner?
Partitioner is the one, okay, is the last step of this one. Okay, so he is the one who will decide that, okay, so when I have multiple reducers, okay, which key should go to which reducer, that should be decided by partitioner.
Partitioner is in service or is there any container?
Okay, see, okay, let me tell you. Okay, so normally when I say map reduce program, okay, reduce program. Okay, so it means it is a combination of map, okay, map functionality, okay, reduce functionality. Yes or no? Okay, under map functionality, what are the things will come? Okay, under map functionality, you'll get okay, input split. Okay, record reader, mapper, okay, and okay, partitioner. Okay, these things will come under mapper. Okay, mapper functionality. Okay, then okay, if you see this one, so reducer output format. These things will come under reducer. Okay, understood, sir. When I say map, okay, so it is not okay. It will not do one thing. Okay, it is a combination of four things equal to map functionality. See, it means okay. All these days, okay, I was referring okay all these things like one mapper. Okay, but now I'm taking you inside the container. Okay, see, so this is the mapper container. Okay, mapper container, reducer container. Okay, so inside mapper container, these things will work, sir. Okay, no, right, okay, there is a mapper launched here, right? Mapper one, huh?
Yeah.
Mapper one launched here, right? Okay, what mapper one will do? Mapper one will do these four things to create the output.
Okay.
Okay, and inside reducer container, okay, these things will work to generate the final output. Understood?
Okay.
Yeah. Inside mapper container, okay, these things will work. Okay, these are the steps. Okay, and inside the reducer container. So here, okay, inside mapper container, it is starting with input and okay, record reader reading the input, record each record from input split and giving it to mapper. Mapper will check okay, whether we need to consider this record or not. Then okay, it will give to partitioner. Partitioner will convert the data into key and value base. Okay, for the reducer, okay, so now reducer is the one. Okay, so for this, okay, mapper input is the mapper output is the input. Okay, and okay, reducer is the one okay, who will do the consolidation and write the output using output format.
But Venkat, one question:
Ah,
how practitioner is in sync? Means all this partitioners are in sync. All are sending
sir,
same
okay,
values to same reducer. Yes, like
so
IT they are sending. Yeah, they are communicating, or how they are.
wait, you know what is this ASCII algorithm?
Yes, sir. Hash value will be same
Ah,
always.
ah, do you know what is ASCII algorithm?
Yes,
You
yes,
know,
yes.
It will generate unique value.
unique value. Okay, so each if I have okay, 10 mappers, each mapper will follow the same algorithm. So each mapper will generate the same output.
Okay, sir. Yeah, got it.
Understood?
Understood, sir. Understood.
So partitioner will run hash map algorithm. Okay, based on that, okay, it will decide okay which reducer should go to which key should go to which reducer. Otherwise, okay, here okay, they both will fight each other. Okay, hey, I will count okay, IT, I will count HR. Yes or no? If I have two reducers, they both will fight, right?
Yes, sir. Yes, sir.
Okay, so I will reducer one say why IT for me? Okay, I will count HR. A reducer may tell okay, I will count IT. Okay, there is a confusion. Okay, to avoid this confusion, okay, what we are coming with, okay, so here, okay, so we have a partitioner which will run a hash key algorithm. Based on that hash key algorithm, it will decide okay which key should go to reducer one and which key should go to reducer two. Okay, understood?
Okay, sir. Yeah, understood.
So, and if it is with 50 reducers, so I have IT 1 lakh, okay, reducer, okay, 30,000 reducer to output, okay, but for third output, okay, so we have only two keys, okay, no third key. That is the reason it is empty output file. Here, guys. So
Yes,
that's
sir.
how it works actually. That's how it works. Okay. And now, okay, what is the relationship between input split and SDFS block, guys? Normally, what is the difference between input split and block? This is block and this is input split. What is the difference between these two?
Logical split and physical split.
If I say block, okay, block may have partial records. What do you mean a partial record? What do you know partial record?
Unsuccessful record.
Huh?
Unsuccessful word.
Half of the record.
Yeah.
Okay. So half of the record. It may be half of the word or half of the record like this, half of the row, anything actually. Okay. It is not like a full line. Okay, full record. I should not say line. Okay, it's not a full record. Okay. So blocks may contain partial records. Okay, but when it comes to split, okay, split will never contain any partial records. Split will honor the complete block boundaries. Inside splits, okay, you will have complete records actually, complete records. Okay, even though half of the record is available in the next block, it will bring that information and attach it here in the split one itself. Okay, and one more thing. Okay, so block is a physical block which is residing on SDFS. Correct or not? It's a physical storage. Okay, but okay, split, is it a physical storage or in memory content?
In memory.
In memory.
Memory. That is the reason. Okay, we will say split is a logical one. Okay, logical means in memory one. Okay, so a file on SDFS may be divided into blocks. We know this one. A file on SDFS will be divided into blocks. So these are the blocks. Okay, records in the file can be split across multiple blocks. If you see the record here, sixth record, half of the record is here, half of the record is here. Okay, so split is a logical block which honors complete record boundaries. So split is a logical block. Logical block means in memory copy. So split is a logical block which is in memory copy of your data or physical block. Okay, but okay, which honors complete record boundary. So this will complete record boundary here. Understood? Okay. So split size will be defined by file input format. Okay, so here the input format. Okay, so split size will be defined in the file input format. Okay, so here, okay, so you can define the split size and all, okay, inside this one, the job configuration class.
Sir, blocks correct count split concept rather correct.
No. So, sir, suppose think like this. Okay, block one, okay, is okay. So block one is like this actually. Okay. Also split concept will come, but there is no change. There is no difference.
Yeah, there is no change, but split will be mandatory.
Yes, split is mandatory, sir.
Okay, sir.
Yes. Okay. Any questions here? Any questions here, guys?
No, sir.
Yeah. Okay. So now running simple MR jobs in Yarn. Okay, we have already executed some simple jobs. So normally, if you see MR job, okay, MR job will place the data in the given output directory. Okay. So whatever the output directory you select here. Okay. Suppose okay here. Okay. So whatever the output directory. Okay. So here okay, I'm saying okay, output 2. Whatever the output directory you select, okay, your MR job will store the output into this directory. Understood? Understood. So here okay, there is a star mark. If the output directory is already existing, what will happen? MR job will fail. Why? SDFS doesn't support override. Suppose okay, now you see SDFS DFS-ls project BLR. So we have output 2 directory is already available. Okay. If you run a job on output 2, let's see what it is saying. You have chosen an output directory as this one, which is already exist. Yes or no? Yes or no, guys?
Yes, sir.
Okay, which is already good. That's what it is saying. That's what it is saying. Okay. And every Hadoop portion comes with a few example structure. This is the example structure. Okay. So using this example structure, okay. If you don't know how to write, okay, jar files, Java programs, okay, you can use this example structure, and okay, you can run your programs, PowerPoint programs or some, okay, or any program. Clear? And application submission in Yarn. Okay, so we have already explained okay, what is this application submission. So client submit the job here. So when I say client, who is the client here?
Alan.
Alan is the one who is submitting the job here. Alan submit the job or application to resource manager. Okay, what resource manager will do? Resource manager will update the application state store, okay, immediately and provide a job ID or application ID, as the reference number. Okay, Now RM chooses any node manager with available resources and launch new application master container and assign MR job or application to it. What first thing what RM will do after updating after updating this report, immediately, okay, it will see who is having more resources, more RAM, okay, more cores, okay. On that machine, it will launch application master. Okay, so in this example, application master is launched here. Application master is launched here. Okay, so then application master creates the job configuration XML, saves to HDFS. What application master will do? Application master will okay, so as soon as it starts, okay, so what application master will do? Application master will create job config XML, job underscore .xml file, okay, and store into HDFS. Correct or not? Okay. Store into HDFS. Application master contact name node and get the location of the file blocks to be processed as part of the job. Now application master will contact name node and ask, hey name node, as part of Wallen job, okay, I need to process sample2.txt. Can you give me sample2.txt file block locations? Okay. So now what name node will do? Name node will reply saying that okay, so your sample2.txt file is having 3 blocks. Okay, this is the block 1, this is block 2, this is the block 3. So this is the where, this is the place where blocks are available. Okay, so now application master understood that where the block locations are available. Okay, now application master contact. Okay, okay. So now using this report, okay, application must identify the required number of resources to process the job and negotiate with the RM to help with the same. So now what application master will do? Application master will read these blocks and okay, try and convert those into splits actually. Now, based on the splits, okay, it understood that how many mappers are required. If I have 2 splits, okay, I require 2 containers, mapper containers. Okay. Then, okay, once it report is ready, with this report, application master will go to resource manager and ask, hey, I have 2 splits, so can you give me 2 containers? Okay, preferably on this one and this one. Okay. So now, okay, what RM will do now? RM will see, okay, so whether resources are available here or not. Yes, available. Okay. So it will give the mapper one here. Okay. And okay, it will check whether resources are available here or not. Yes, available here. Okay, it will give the mapper here, one more container here. Okay, so now both the containers are ready. So now both the mapper containers will be reporting to application master. Now application master will tell, hey, mapper one, okay, this is your input split. Okay. So you start processing this data, and okay, application master will tell mapper to, hey, this is your input split, start processing the data. So each mapper will start processing the data. Each mapper will start processing the data and get generate the output in the local file system. Okay, so each mapper will generate the output and store into local file system. Mapper one also store into local file system. Mapper two also store into local file system. Okay, so this is done. Okay, what next? After this one, what will happen? Okay, so now both mappers will be released by application master. Now reducer will come into picture. Okay, so whatever I explained, I'm just okay. Putting those words in the putting that information in the words here. Okay, so application master launches the mapper containers and complete the work. Then a application master request for the reducer containers. Okay, and okay, so it will RM will give the reducer container. Okay, so now application master will tell reducer container what is their input. Okay, so now reducer will take the input. Okay, mapper output as input and it will start processing the data. So once reducer generate the final output, okay, it will save that output into the final output into HDFS with the help of name node. Okay, so here the complete history. Okay, so all the running mappers and the reducer task can be tracked under job history JSON file. So which mapper is launched at what time? Okay, which mapper is closed at what time? Okay, how much time each mapper has taken, and how much each when reducers are launched, how much time each reducer has taken. All that information will be maintained in the job history JSON. Okay, so again this file also stored on HDFS. Understood, guys? This file also stored on HDFS. There are any questions? Okay. So now, once everything is completed, okay. So application master is responsible for end-to-end execution of the jobs. If any task is failed during the execution, okay, guys, okay, this failure points, okay, this failure points, I'll put it, I will cover in the next slide, okay. So what will happen if mapper is failed? What will happen if reducer is failed? Okay, what will happen if application master is failed? What will happen if RN is failed? So these are the failure scenarios which I'll be covering in the next slides, okay. So now application master will be updating the task status to resource manager and clients on the frequent intervals. So application master is the one who will be updating the task status. Okay, mapper this much person completed, mapper reducer this much person completed. All this information will be updated to client, okay, on regular intervals. Okay. Once all the tasks are completed successfully, application master send the job list and the logs to job history server. Okay. So you don't know this point at this moment. Okay. So you keep it aside. Okay. So now at the end, resource manager instructs node manager to release all the allocated containers used for that application. Okay, so resource manager will instruct node manager to release all the containers. Let it be mapper container, reducer container, or application master container. So this is the end of the job. Understood? Okay, this is how, okay, a map reduce program, okay, will work, okay, from the time you submit and, okay, from the time it close or to the time it close. Okay, and this is very, very, very important question in the interviews case. Okay, they will ask, okay, what is the yarn workflow? What will happen when somebody submit a job? What will happen in the behind scenes? Okay, almost, okay, we are struggling for this, okay, from last 6 days. I guess this is the batch where I explained, okay, 6 days of yarn framework. Normally I take 3 to 4 classes, actually 3 to 4 classes, but this class, okay, I explained for this batch I explained for 6 classes. But I don't know how many of you understood the concept or not. Okay, fine, guys. Okay, so that is about application submission. The next concept is core and memory allocation in yarn. Okay, this is, okay, we have already discussed here. Okay, so the core and okay, RAM will be allocated here. Okay, now if you see here, guys, okay, so now let's say this is the node manager. You see, this is the node manager. Okay, in this node manager, what are the total resources available? What are the total resources available? Tell me, what are the total resources available? Total resources are, okay, in each machine 8 cores, 32 GB RAM. I'm just giving example. These are the total resources available, 8 cores and 32 GB RAM. This is the total available resources. Total resources. Okay. We use all the total resources, okay, for yarn. Okay, we need to keep something for OS also.
OS also.
So normally 20% of this is 100%. Okay. Okay. This is for OS and, okay, 80% for yarn. OS 20%. Okay. And 80%. Understand, guys? Understand?
Yes, sir.
Yes, sir.
So if I have total 100% resources, okay, 20% will be given to yarn. Sorry, OS. Yes. And 80% resources will be given to yarn. Understood?
The total resources for node manager and data node is same, yes.
Sir, okay, this node manager server. This is server.
Okay, sir, got it.
Okay.
This is server, not container. Okay, got it.
Server one, okay, inside this one, node manager one is running. So overall server capacity, sir. Understood?
Yes, sir, yes.
Overall server capacity. This is overall server capacity. Overall server capacity is this much, okay? But we need to keep something for OS, okay? We are giving how much? 20% for OS and 80% for YAN. Okay. But where you will define, okay, so these are the resources, okay, we are giving for YAN. We will define in the YAN site XML. Okay. If you see here, UI user local etc Hadoop YAN site XML. So here, okay, here you can see node manager. Okay. So node manager course. Okay. This is the node manager course, node manager memory. These are the properties. Understood? Okay. So you will define inside the YAN site XML. Inside YAN site XML about this one. Okay. This one you will put in the yarn-site.xml file. Understood? Understood or any questions?
Yes, sir.
Okay, this will be defined under yarn-site.xml. Okay. But okay, see, if we define okay this 80% yarn-site XML, okay, what yarn will think? Okay, see from this machine or from this node manager, I have only these many cores and this much RAM. Even though it has 8 cores, 32 GB, it will not think okay about 8 cores. Okay, it will think okay, so I should use max of 60. Okay, okay. For me, the availability is only 6 cores and 26 GB RAM. Understood? Okay, so this is the total capacity given for YAN from this server, from this server, from this server. Okay, but okay, now inside these node managers only, I need to launch the containers. Okay, when I say launch container, so if my YAN capacity is 6 cores, 26 GB RAM, can I launch okay 3 GB container here? Huh?
No.
Tell me guys.
No, sir.
See, my allocation itself is 26 GB, but can I launch? Can I ask okay node manager to launch 30 GB JVM?
No, sir.
No, no, sir.
That means okay, the number of cores should be less than or equal to this one. Number of size of JVM also should be less than or equal to this one. Okay, you cannot create a container with 7 cores, or you cannot create a container with the 27 GB RAM. Got it? So those will talk about okay this one. Okay. Container maximum cores, minimum cores. Okay, maximum cores and minimum cores. Understood? Understood or any questions?
Yes, sir. Understood.
Yes, sir.
Yes, sir.
So inside the container, okay, so here it is like this, sir. So this is the server. Okay. So okay, let me tell you how it works actually. Okay. Suppose okay, this is the server, sir. Server one. Okay. Inside this one, server one, okay. Node data node service, okay, node manager, both are running. Understood? Okay. So now what will happen? What will happen? This total one, okay, will be divided into 2 parts. Okay, one is for edit text. This is for YAN. 80% resources. Okay, 80% resources. %, resources. Okay, so this is for OS. Okay, this is for YAN. Okay. So from this server, 20% will go. 20% will be given to OS and 80% will be used by YAN. Okay, in this 80% only, I need to launch the containers. Okay, so can I launch a container? Okay, so YAN container should be okay, container 1. Container 1. Okay, so maybe until you have enough space, okay, so enough resources, you can launch container 2. container 3. Okay. So like this, okay, you can have the number of containers actually. Okay. Container 3. Okay. Then container 4. So once container is done, one is done, okay, release it. In the same place, okay, you can launch container 5. Container 2 is done, release it. Okay, in the same place you can launch container 5. So like this, okay, the containers will be. So the containers, okay, these containers should be, okay, this container can be application master, this can be mapper or reducer, anything, okay. But all these containers should be less than this, okay, less than or equal to this one. Or all these containers should fit inside this 80%. Sum of all these containers should never cross, okay, this 80%. Understood? Understood, sir?
Yes, sir.
So all the containers should not cross 80% capacity here. I mean, okay, this yan total capacity. Understood?
But sir, then how data node will run if 80% has been taken by this?
Data node service will run in this remaining 20%, sir. Data node service will run
Okay.
on OS resources. Understood? Okay. Sir, even node manager also service also running with the OS resources, right?
Yes, sir. Yes.
80% resources are used to launch containers. Okay? Yes or no?
Yes.
See here, data node also JVM, node manager also JVM, this containers also JVM. Okay? So if this is the server, this is the OS area, and this is the OS area of 20%. Okay. And this is the LAN area of 80%. Right? Okay. Now inside this OS area, node, okay, data node service will run. Data node service. Okay, node manager service will run. Understood? Inside this one. Inside this area, okay, container 1, container 2. Understood, sir? No? Huh?
So, sir, all daemons will run in this.
Exactly.
OS.
All the daemons will run inside the OS area resources with OS area resources. Okay. These are okay YAN containers. Okay. And containers will run inside this one only. Okay. Container will launch. Okay. Work. Continue their work. Close it. Launch. Okay. Complete the work and close it. Understood? So these will be like these containers will be on and off. They will not run continuously. Okay. So each container may run. Okay. So if it is a mapper container, thumb rule is that okay, less than or equal to 2 minutes. If it is a reducer container, thumb rule is that less than or equal to 5 minutes. Okay. Okay. If it is a mapper container. Okay. So mapper container means thumb rule is that okay, it should run. If it is a mapper container, it should run between okay, so 1 to 2 minutes. Anything is running less than 1 minute. It means okay. What does it mean? So I have a set of mappers, guys. Okay, the mappers are all the mappers are taking okay, taking 30 seconds to complete their work. What does it mean?
We need to reduce the mappers then.
Exactly, sir. Okay, so they are taking 30 seconds means okay, you have more people and work is getting completed in less time. Okay, so you need to reduce it. Let's say you have set of mappers. Okay, on average they are taking 3 minutes. What does it mean? What does it mean? So you are giving more work to mappers. Okay, it means you are running less mappers. You need to increase more mappers. Okay. So in the same way, if you see the reduced container, this will run for okay, so 5 to 10 minutes. If reducer is running for more than 10 minutes, you should increase more reducers. If a reducer is running for less than 5 minutes, you should increase you should decrease reducers. Understood? Understood or not? So all the mapper containers or application master container or reducer containers, okay, will be running in this area, and Hadoop daemons will be running in this area. Clear? So this is called as server 1. So server 1. Any questions? Okay, so this is the place where we will be defining, okay, how much should go for a node manager, how much, okay, inside that, what is the maximum size of a container, minimum size of a container, okay, then okay, maximum size means okay, maximum cores for a container, minimum cores for a container, maximum RAM for a container, minimum RAM for a container, okay, then okay, what is the maximum cores, okay, for mapper, if it is a map, okay, when it's a container, inside this container, I run map task, so container 1, if you run map task, okay, task, okay, it is called as a mapper container. Okay. In container 2, we are running okay, reduce task. Okay, you will call it as a reduce container. Mapper container, reducer container. Okay. Inside container, okay. So inside container, you are running okay, container 3, you are running application master. Okay. So then it is called as a application master container. Got it. So container is a place okay, to run your task. The task can be application master or map task or reduce task. Okay. So anything can be run inside a container. But okay, if I want to call it like mapper container, when I will call it as a mapper container, if that container is running map task. If that particular container is running a reduce task, I will call it as a reducer container. If that particular container is running an application master, it is called as application master container. Clear?
Yes, sir.
Yeah. Okay. What are the advantages of YARN framework? Guys? When I say advantages of YARN framework, okay, so it is a flexible resource model with multiple data processing algorithms. So what is a flexible resource model here? When I say flexible resource model, so when I say YARN, okay, using YARN, I can run a lot of jobs actually, okay, or different type of jobs, okay. Sir, okay, do you think a different you will have different type of jobs? Huh? See, normally job is job, right? What is type of job? Normally, when I say job, it's a job. Okay. Okay. But Jan is saying that you have type of jobs. Can you do the same work in different ways, guys? Can you give me one example?
Going to office by bike person.
Can you do the same work with different in different ways? Yes. Okay. Going to office. This is the work. Okay. You can go to office by bike or by car or by bus, by train, metro, anything you can use. Okay. You want to transfer money. So transfer money, what are the different ways we have, guys? NEFT is there, NEFT is there. Okay. RTGS is there.
IMPS.
Okay? IMPS is there. At the end of the day, transferring money. Okay, all these different ways will do transfer money transfer only, right? Okay. Okay. What else we have to transfer money? Google Pay. Okay. Okay. What else?
ATM.
Huh? ATM. Maybe
ATM.
yes, ATM.
Paytm, sir.
Paytm, yeah. Okay. So like this here. Now transfer money is your work. But okay, you can do this work in different ways. Yes or no? Okay. In the same way, okay. Yarn also can run different type of jobs. Okay. Now, what is the difference between What is the difference between these three guys? What is NEFT? You all know what is NEFT?
Yes, sir.
What do you like to be done?
Batch wise, like National Electronic Fund Transfer, it can
How it works?
Transfer funds in
How it
bank.
is different from IMPS or RTGS?
Fraction of minutes or fraction
Processing can be done in batch wise, sir, in after transaction.
What do you mean of batch wise?
Like half an hourly basis or half an hourly basis.
For each 2 hours, it will transfer.
Okay, so normally, see if you say NEFT transaction, what will happen? It will go by batch wise. Okay, what do you mean of batch? See, normally what bank will do? Okay, what bank will do? It will divide the time. Okay, a day into 2 hours slot. Okay, 6 a.m. to 8 a.m. Okay, 8 a.m. to okay 10 a.m. Okay, it means okay, whoever does NEFT transaction between 6 a.m. to 8 a.m. Okay, their okay data will be all those money transfers will happen at 8:05. Understood, sir? Understood. So you transfer money at okay 661 or you transfer money at okay 7:59. Okay, 8:05 a.m. only. Okay, all the transactions you do between these 2 hours will go at a time at 8:05. This is the NEFT. Okay, but when it comes to NEFT, again, okay, you will have limits. Okay, so maximum is 2 lakhs. 2 lakh rupees you can transfer using NEFT. This is a batch mode. This is a batch mode. Batch mode. Okay, so you can transfer the funds okay, up to 2 lakhs. Okay, so but okay, that will go by batch. Okay, this is RTGS. RTGS also again of a batch only. Okay, again the same thing. Okay, same thing, but okay, it will go. Okay, if you want to transfer anything, okay, more than 2 lakhs. More than 2 lakhs, okay, you will use RTGS. But IMPS, instant money transfer. Okay, it's real time. Okay, so if you send money within next second, okay, so 1 or 2 seconds, okay, the money will be taken to your friend account, other account otherwise. Yes or no? Okay, so these are called batch jobs, real time jobs. Okay, even Google Pay, Phone Pay. Okay, so okay, Paytm, all these comes under okay, under this only. Will you agree with me? Instant money transfers, all these are.
Yes, sir. Correct.
Okay, instant money transfers. Okay. So in the same way, when it comes to Yarn, okay, Yarn can do batch jobs. Okay, interactive jobs. Okay, online jobs. Interactive jobs means, so normally if you see batch job, okay, batch job will have one input and one output, or input and output. Okay, so if you run a job one, okay, it will take input and okay, it will apply some logic on top of that input, and it will generate one output and save that output to STFS. That is batch job. But when it comes to interactive job, one job output is the input for other job output, other job. Okay, such jobs also you can run on Yarn. Online jobs. Okay, you want instant result. Okay, what do you mean? Can you give me one simple example of online job? What do you mean of online job here? Huh? Can you give me one example of interactive job, guys? So batch job, okay. Can you give me an example of batch job? Word count. Is a batch job or not? We are doing word count. Okay. So for that word count job, okay, we are giving input as sample1.txt and output, okay, we are giving the output directory. So what is happening? Okay, when you run a job, it is taking input as sample1.txt and generating some output, and that output will be written to HDFS. Yes or no? Once the output is written to HDFS, your job is getting completed. That is batch job. Okay. Can you give me an example for interactive job? Huh? So okay, I'll give you one simple example. Okay, let's say you are withdrawing money. You are withdrawing money. Okay, so what you will do if you want to withdraw money? What you will
Go
do?
to ATM, insert
ATM.
card. Yeah.
So go to
Insert.
ATM. Okay, you will insert the card. You will enter
Enter
amount. You will
entries.
be.
Yeah. Then
That means okay.
we'll
So what?
enter amount.
Yeah. So what ATM will do? Once you
ATM.
provide all the details, okay, ATM will dispatch money. Yes or no?
Yes. Yes.
Dispatch money. Yes or no? So you want to withdraw 10,000 rupees. Okay, so you have given okay, you inserted your debit card and okay, then you have given it your PIN code. Okay, amount okay, 10,000, everything done. So click on submit, final submit. Okay, so then ATM will dispatch the money. Okay, so is it the end of the its work or okay, is there any other work is there for after dispatching money? If the dispatch is successful, okay, if the dispatch is successful, if this job is successful, okay, it will invoke okay one more job. Okay, okay, update account information. So what is this update account information? Let's say previously you had okay, so before doing this activity, you had 1 lakh rupees in your account. Okay, maybe after completion of this money dispatch, okay, if you update your account information, okay, you will have 90,000 only in your account. So no. Okay. Suppose okay, see now this is okay, this job you are executing if this is successfully completed. Otherwise, are you executing directly this one? You will never execute this job directly. Okay, this job is depending on some other job. Correct or not?
Yes.
Okay, so these are like interactive jobs. Okay, if this job is successfully completed, then only this job will be initiated. Okay, so this job okay, success status will be the input for second job. Okay, these are interactive jobs. Okay, online jobs. What is online job?
Booking movie tickets.
It, okay, good, madam. Good. Okay, so online jobs doesn't mean okay, booking movie tickets online. Okay,
Or
so let
like travel tickets or something.
travel ticket. Okay, so yeah. Okay, okay. Let me give you one example, real life example for online job. Okay, so let's say I mean you all know how to withdraw money from ATM. Okay, let's say if you want to withdraw money from ATM, what you will do, you'll go to ATM. Okay, so you'll insert your debit card. Yes or no? You'll insert your debit card into ATM machine. Correct?
Yes, sir.
Okay. So now it will take some time. Okay, maybe a couple of seconds. Maybe one. Some ATMs will take only 1 second, and some ATMs may take two, 3 seconds. Okay. Suppose okay, if there is an issue with the card, what it will say? It will immediately throw error saying that card error. Okay, unrecognized card.
Decline.
Yes or no? Decline. Yes or no? Okay. So what is happening? Okay, to show this message in the backend. Why it is showing such message? But okay, is this message showing to all the cards or only for few cards?
If we enter wrong ATM PIN number or
No. I forget about ATM. I just inserted my card. That's it.
it should be able to read the chip. No?
So in the backend, what is happening? Okay, so when you insert your card, when you insert your card into ATM machine, okay, every card will have a chip, right? Huh?
Yes.
Yes.
Inside the chip, okay, so you'll have the card details actually. Okay, so it will take the card details, and with those card details, it will go and check in the source system saying that okay, whether this is a valid card or not. Okay, if it is invalid card, okay, immediately it will throw error saying that okay, invalid card or card error, chip error, whatever it is. Okay, if it is a valid card, then what it will do? It will go to the next screen. Okay, so enter your amount, then enter your okay, then if you press enter, okay, then okay, enter your PIN. Okay, it will take you to the next screens. Okay, so this is like online job. Okay, on the fly, it is checking the information and okay, taking a decision whether to proceed further or stop it here. This is called an online job. Okay, it is not like booking IRCTC tickets or movie tickets. Okay, so then okay, streaming job, live data. Okay, graph jobs. Okay, what do you know of graph job? Have you ever used graph jobs? Normally, graph jobs means okay, so you have some data, you are creating some graphs and charts on top of that. That's a normal one. Okay, but apart from that,
When a job runs, we can look at the graph and say how the CPU performance
that
is.
is like a normal graph jobs. Okay, So now, okay, let's say okay, you want to go to okay, your friend location. Okay, he or she shared the location with you in WhatsApp. Okay, so now what you will do, you will open WhatsApp and you will click on that location. Okay, then it will show you the path from your location to your friend location. Yes or no? It means okay, it is putting a graph, okay, from your location to other location. So those are called as graph jobs. All Google Maps okay run graph jobs in the backend. If you tell source and destination, like immediately in the backend it will run a graph job and it will show you the path.
Uber app
Okay.
also will produce
Sorry?
a Uber app.
Uber, Ola. Okay, so not only that Uber or Ola. Okay, so
Yeah,
wherever, yeah, wherever you see Google Maps, okay, so they run the graph jobs. The same way we have reef jobs, okay, SAS and other jobs. So using Yarn, okay, you can run these many different type of jobs. Okay, it is not only one job, one type of job. Any type of job you can run using Yarn. Okay, and high availability for components. Okay, so we will talk about that. What is high availability for components in the next slides. Scalability and high cluster utilization. What do you mean scalability? You can go up to 10,000 node managers. Our data nodes also we told same thing, right? In Hadoop 2x, okay. Guys, in Hadoop 1x we don't have Yarn. Understood? In Hadoop 1x we don't have only Yarn is introduced. Okay, earlier okay, it was like okay, so we have job tracker, task tracker, which runs only batch jobs. But later they introduced Yarn in Hadoop 2x, which can run batch jobs, iterative, interactive, streaming, graph, all these jobs. Okay, so if you see the scalability and all, okay, in Hadoop 2x, okay, you can go up to 10,000 node managers. In Hadoop 3x, you can go up to 25,000 node managers. Okay, and log aggregation. I'll cover what is this log aggregation in the next slide. Okay, so these are the different advantages with Yarn framework. Got it? Any questions?
Sir, question, yes, sir.
Yes, sir.
Sir, like you have written several tools for interactive jobs. There is Tej and then
Yes.
online for edge-based
Yeah.
streaming Storm. So my question is, MapReduce is only for batch, right?
Yes, sir.
We have to use some different tools, right?
No.
Through
Sorry, sir.
Yarn, we can.
Sorry.
No, in Yarn, MapReduce is only used for the batch processing. Others
Yes.
for interactive and all, we need to use some other tools, right, sir?
Yes, sir.
They will utilize the Yarn job technique, but the tools and mechanism will be different, right, sir?
Yes, sir. Yes, yes.
Okay.
Okay. So next, okay. So we will go a little bit inside and try to understand what is job or application difference. Okay. So guys, okay. Now we understood that okay, whenever you submit a job, RM is giving this one. RM is giving a job ID. Correct or not? Job ID or application ID. Correct? What is this job ID? What is this, guys? Okay, this is a job ID or application ID. Okay, so this is the job ID or application ID. Okay, this is called as a job ID or application ID. Okay, this is called as job ID or application ID. Okay. Job or application ID. Okay. Now, how this job ID or application ID will be created? What is this number? Have you ever thought? What is this number? What is this number, guys? Now let us take this number. Normally, if you see Linux, okay, in Linux, okay, how date time will be considered, guys? How date time will be considered? So we have some, okay, date time will be considered in the Linux timestamp. Okay. So this is the Linux timestamp here. This is the Linux timestamp. Okay. So it means okay, this represents one date time. Okay, date time. This includes date time. Okay, date time with milliseconds. Understood? Date time with milliseconds. Okay. But okay, now okay, if you remove the last three, okay, it is a date time with seconds. See, when I say milliseconds, okay, so you will have last three digits also. If I say seconds, okay, I removed the last 3 seconds. Okay, now you see this one is you try to convert this into human readable format. This is a Linux timestamp format. You try to convert this into human readable format. Okay, so date-d at the rate, give this number. What it is saying? What it is saying is it is converting this into human readable format. Okay, Thursday, March 24, 9:04 a.m. Okay, so this is the date time it is saying. Okay, now what is this date time? About, click on about. Okay, so what is this? Can you see this one, guys? When resource manager started on? Is the same thing or not? Plus 5:30 means okay. So yes, it is the same thing or not? Huh? So it means okay, your job ID or application ID will be okay, created like this actually. Okay, so application underscore. Okay, what is this number? Start time of RM. Understood? With including milliseconds. Okay, underscore. Okay, job counter. What do you mean job counter? Okay, now when you start your resource manager, first job, okay, after starting resource manager, if you submit a job, it will start with okay 001. Okay, so job counter will start with 001. Okay, we submit second job, okay, 002. Like this, okay, for every job you will get okay, different. Okay, so now application, okay, it will start okay after starting resource manager. Okay, this is the first application. Okay, this is the second application. Okay, like this it will keep on going. Yeah, that is the reason you will see 1 2 3 4 5 6 like this. If I submit the next job, it will give me application and start time of resource manager underscore 0007. It will give. Okay, understood. So like this, okay, one fine day it may reach. Okay, normally, okay, correct or not? In 1
The
month,
day by day, the job will change, right? The name of the job.
day by day means, sir, okay, let's
Every
take,
day it will start from 1, yes, sir.
okay, so let us take this scenario, sir. Okay, let's say I started a resource manager on this day. The start time. Okay, RM start time. Okay, RM start time is this one. Okay, so from here, okay, what will happen? Whatever the jobs you submit now, okay, the job IDs will be like this. Understood? Okay.
Yes, sir.
Now, okay, again, okay, so now at this time, let's say March 27th you restarted. What will happen? In 3 days it is running, same resource manager is running for 3 days. Okay, on 27th you restarted. Okay, on 28th you restarted. Okay, what will happen now? Now again, okay, it will start running. Okay, maybe 28th it will be start time, maybe some different number, right? Okay, and counter will start again. But okay, this start time is different. This start time. Understood? Again, okay, it restarted once again. Okay, so again it will be like, okay, let's say March 31st it restarted again. Okay, so you will have a different start time. Okay, you will have a different start time. Okay, and again counter will start from 001.
Only time will be changed. The date.
Only time. No. Every time you start, okay, the counter also starting from 001, right?
Yeah.
Yes or no?
Yes.
Okay. Suppose, okay, now you started on March 24th, okay, and okay, you restarted on, okay, again, you restart March 28th. In between, okay, how many days we have? This time to this time, 4 days we
4
have.
days.
Yes or no? In these 4 days, okay, you can run any number of jobs, right?
Yes.
So now, okay, I may run 9,000, okay, this job also, okay. Once this is completed, it will become 10,000. Understood? Okay. I may run, okay, may run, okay, 20,000 job also, okay. I may run 30,000 job also, okay. So, like this, okay, you can run any number of jobs between, okay, with this time to this time. Okay. Now, if you see our cluster, guys, okay, our cluster, okay, in 24 hours, okay, we run 3 lakhs jobs. How many jobs? In 24 hours, we run 3 lakhs jobs. Okay. Now, if I restart time is okay, 4 days. In 4 days, how many jobs it will run? My RM will run 4 into
1 lakh.
3, 12 lakh jobs it will run. Okay. It means before, okay, before I restart my this one, maybe this is like, okay, 12 lakhs. But it is maybe 12 lakhs. Understood? And is there a rule that, okay, you should restart your RM, okay, every 4 days once, okay, 3 days once, or 2 days once? Is there a rule?
No, I guess.
There is no rule at all. Okay. So at times, okay, your RM will run for, okay, 2-3 months also. If I start, okay, without any issues, it will run for 2-3 months. At times it will run for six months also. But normally every 3 months once, okay, minimum, okay, we will do the patching part. Okay, that is the reason, okay, we will restart. So minimum, okay, 3 months it can run if there are no issues at all. Understood? Understood, or any questions?
Yes, sir, understood.
So this is so job ID or application ID will be created like this actually. So job ID or application ID will be created by application
So,
underscore
sir,
start.
if in real time any job gets failed and we need to check that, then based on timestamp only, we need
Not based on
to
time steps, okay.
provide.
See, any job is failed, okay, you should know the job ID. Only you can check it. Otherwise, how can you check it?
Yes,
What you can if you have, okay, so resource manager start time. That is not sufficient, right?
are not sufficient, correct.
In a day, I run 3 lakh jobs. Okay, which job is your job?
Hmm. Yeah, job ID only required.
Job ID
Yes.
is very, very important. Understood?
Yes, sir. Sir, if let us suppose if there are bad jobs for transactions,
Okay.
okay. So customer is doing transactions and jobs are running in HDFS, and out of 15 transaction, customer did one failed, and
Okay.
now query came for that one transaction. So how will it be like how? And they asked, okay, you check this job. Then they
If
will be giving job ID. The
they
person
have
who
to
is
give,
working.
sir. Sir, okay, without job ID as admin, you cannot do anything. Understood, sir?
Okay, sir. Understood. Yes, yes. Okay, okay. Got
So
it. Yes.
without providing job ID, if some issue is there, developers, okay, must provide the job ID. Then only you can check.
Okay, sir.
Otherwise, okay, you have 3 lakhs jobs in a day, sir. Which job you will check? Okay, do you think if I run 3 lakh jobs, all 3 jobs will run successfully?
No, no.
They will fail in between, right? Few jobs. Okay. If I run 3 lakh jobs, at least, okay, 10,000 jobs will be failed. In the 10,000 jobs, okay, which is your failed job? Okay, so it's very difficult, guys, actually. So without job ID, understanding this is very, very difficult.
So job ID is who will a developer or support team who will be
Who will run the
maintaining
program?
this record.
Who will run the jobs?
A developer basically. Code is developer's code. Yes.
Developers work. Okay, so running job is developers work. They will run. Okay,
Mhm,
they
yes,
will
sir.
note down their job ID.
Okay, okay, sir. Got it. Yeah.
Okay, they'll be knowing their job ID.
Okay, sir.
Yeah. Okay. So now this is the application. Okay, this is the job ID. Okay, but each job ID. Okay, when I say job ID may contain okay multiple mapper task and reducer task, right? Multiple tasks. Yes or no? Okay. So this is the job ID. Okay. So here you can see application job ID or application ID are generated by resource manager. This is the application number. So this number is like start time of the resource manager, and this is the job counter. Okay. So now when I say job, okay, job or application, it is a combination of okay. So map task, yes or no, and combination of this task. Okay, I'm putting this yes okay in brackets. I can have a job with only one map task and one reduce task. Yes or no? Yes or no, guys? Okay. I may be having a job okay, with the 10 map task and okay, one reducer task. It's up to you. Okay. So it can be one map, one reducer, okay. Okay, multiple maps and one reducer, okay. One map, okay, multiple reducer, okay. Multiple maps and multiple reducers. One map, no reducer. Multiple maps, no reducer. Yes. Okay. It depends actually. Okay. It's okay. Can I run a job without reducers, guys? Can I run a job without reducers?
Yes, sir.
No, sir.
Huh?
No, sir.
No.
We'll see that. Good thing. Number of reducers I'm giving like 0. Okay. Okay, we will do one thing. So VI okay, sample 5.txt. Okay. Hello, who are you? I am fine. How are you? Okay. This is the amplify.txt. SDFS, TFS, file, sample.txt, project, BLR, under project BLR. Okay. It is SDFS, TFS, hyphen LS, project BLR. Okay. Now we have samplify.txt. What is the size of this one? Samplify.txt 44 bytes. Okay, but replication factor equal to 3. Okay. So now I'll execute a job on this one. Okay. Execute a job. So now I will execute a job. Output 5. Okay. Input is amplified. Okay. And number of reducers equal to I will give. I will run with multiple ways. Okay. I will run with one reducer. Is it fine? It's okay. I'm running with one reducer.
Yes, we can.
Okay. So output 5 will contain one reducer output. So this is the job application ID. This is the application ID. This is the application ID. Okay. With one reducer. Okay. So we'll see the output here. Is it completed? The work? Yes, the job is completed. Okay, where I can see the output? This is the location. I can see the output. Output 5. Okay. Yes, DFS hyphen LS. So here this is the output. Okay. DFS hyphen cat bar tar. What it is saying? Hello once. How came? 2 times. I came 1 time. Yam came 1 time. R came 2 times. Fine came 1 time. You came 2 times. Yes or no? Is it a word count or not? Simple word count.
Yes.
Okay. Now what I will do? Okay. I will run the same job. Okay. Same job. Okay. With 2 reducers, guys. What will happen? I'm running the same job with 2 reducers. What will happen?
2 files will be there now in the same, in output 6.
Yeah. Yes. Yes. Okay. Now if you see, plus output 6. Okay. Since you use 2 reducers, how many tar files are there? 2 outputs. Okay. So SDFS DFS hyphen cat part tar. Okay. So cat. Okay. See here, yes, what happened? Both reducers shared the work. Yes or no? Why it is not shared equivalent work? Why it is, see, earlier if I use one reducer, okay, how many words we have? 1, 2, 3, 4, 5, 6, 7, 8. All 8 words are counted, 8 words were counted by single reducer. Correct or not?
Yes.
If I use 2 reducers, okay, reducer 1 counted only 1 word, reducer 2 counted 7 words. It means did they share the work or not? Huh?
They shared, but they
Shared,
didn't
but
share
it's not
equally.
They shared the work, but the output is same, right?
Yes, sir.
Yeah,
Output is
output is
same, but okay, there it is coming in single file, here it is coming in 2 files. Yes or no? Huh? Yes or no?
yes.
Now, okay, I will run the same job with, okay, with the 3 mappers, 3 reducers. Okay, so I'm running with 3 reducers. Then, okay, how many output files I'll have?
3, sir.
3 output files I'll have. Okay, now done. Okay. So now I cat first one. How many words it counted?
3.
First reducer 3 words. Second reducer counted only 1 word. Third reducer counted 3 words. Okay. Total only 7 words. How many words are there here? 1, 2, 3, 4, 5, 6, 7 words only, right?
Yeah.
7 words. Okay. So in the second time, if you use 2 reducers, 1, 6. Yes,
Yeah.
sir.
1,
If I
6.
use 3 reducers,
3, 1, 3.
3, 1, 3. 3, 1, 3. Okay, so it means like if I use single reducer, see, 1 reducer, all 7 came to the same thing. Yes or no? Okay. But if I use 2 reducers, okay, reducer 1, reducer 2. The second example, okay. So here, reducer 1 has got only this one. Okay. Reducer 2 has got the 6 words. But okay, is the output same? Number of output records are same, right? Yes or no? Now if I say reducer 1, 2, 3, 1, 2, 3, third reducer. Okay. Now what happened? Reducer 1 is this one. Now yeah, this is the reducer 1. These 3 words it counted. Okay. Reducer 2 counted, okay, only this one. Reducer 3 counted these 3. Okay. But okay, because of number of reducers, output is changing.
Okay.
Not changing. Okay, but it is coming in different files. Very simple.
There is no balance.
Okay. But okay, why it is coming like, okay, why it is not equally loaded? When I have 7, okay, it can take, okay, 3 and 4, right? Or 4 and 3, right?
Yes.
Here also when I have 7, okay, 2, 2, 2, 2, 2, 3, right? They can take, right?
Yes, yes.
See why it is coming like this? It is purely based on the hash key algorithm. When I run a hash key algorithm on these seven lines, okay, it got like, okay, so one has come one side, okay, other 6 have come other side. That is the reason it came like this. Okay. Now I will do, okay, what I will do, I run the same job without any reducer, guys. I run output 8, reducer 0. 0 reducers. Okay, we'll see. Is it running? When I say 0 reducer, is it running or not?
It's running.
Yes, sir.
It's running. It's completed. Okay. So now what I will do? plus output 8. Now you see, what is the name of the file, guys? What is the name?
M00.
So here, okay, no, it is part M, part R. What does it mean?
Mapper.
M means mapper. Okay, so in this job, okay, no reducers were run. Okay, that is the reason. Okay, your mapper output is the final output. Now you see the mapper output. Because you want the consolidated output.
Yes, correct.
What is the use of segregated output?
But in this case, task is failed, sir. RM will give.
Huh?
Without reducer, a segregated output can be treated as output.
Sir, can come back, sir.
Without reducer, so that segregated output can be treated as a output of
Final output.
Final output.
Yes.
But not consolidate.
Not consolidated one. Okay, sorry guys, yeah. Fine. Now come back to the job ID application ID. So this is the job ID. So when I say job, okay, so job may contain one or more map task and one or more reducer task also. Okay. So let us take this example. Let us take this example. Okay. So this is the job 006. Okay. This job is having how many mappers we have, guys? This job?
2.
This job. How many mappers we have?
2, sir. Mappers, 1 reducer.
2 mappers. 2 mappers and 1 reducer. Correct or not?
Yes, sir.
So 2 mappers and 1 reducer. Okay. So map task. Okay. 2 map task. Okay. 2 map task and 1 reduce task. Okay. How the task IDs will be created when you click on a map, okay, or when you click on map task? How the task IDs are created? How the task IDs are created? Wherever you have application, okay, so this is the one. Wherever you have application here, that application is replaced by task. Okay, and okay, the next number is coming as it is. This full number is coming as it is. This application is replaced by task. Okay, next number is coming as it is. Underscore M. What does it mean? Underscore M.
Mapper task. Mapper job.
Mapper task. Okay. So what is the which mapper task? 0, 0, 0. It means the first mapper.
First mapper task.
So mapper task count will start from 0. Okay. This is the map. M1 means okay, second mapper task. So no. Okay. In the same way, can you guess okay, how the reducer task will be? Task
This will
underscore.
change R.
Okay. M2 R. Okay. And this number?
0, 0.
0 or 2?
Reduce.
0, 0, sir.
0 only. Okay. So all the mappers count will start from 0. All the reducers count also start from 0. Okay. So, but okay, this is the task ID. This is the first map task, second map task. Okay. First reduce task. Clear? Are any questions?
Clear, sir.
So this is the job ID. So job may be having multiple tasks. Okay. Task ID will be created like this. Wherever you have application, that will be replaced by task. Okay. And and it will add a suffix like m underscore. Okay, your mapper ID, map task ID. M underscore 0 means map task 0. Okay. Map task 1. Okay, reduce task 0. Understood? Okay. So now, guys. Okay. So now your this is your application. Your application is divided to 2 mappers and 1 reducer. Okay. So this is the map task ID. Okay. These are the map task IDs. This is the reduce task ID. Okay. Now what will happen? Okay. What will happen? Every mapper task will have attempt. What is this attempt, guys? Let us take this scenario, guys. Okay. Now mapper task 1 failed. Okay. Mapper task 2 succeeded. What is the failure reason? Okay, I will talk about that later stage. Okay, but due to some reason it failed. Okay, so now see, I have 2 mappers. One mapper failed. Only one mapper is successful. Can I start my reducer with only one mapper output? Huh?
No, sir, you cannot.
Why?
Because the output is not input for the reducer is not complete, right? So it will wait for the fail to be succeeded. So in that case, it will
Okay,
be.
so it means if due to some reason if any mapper is failed, okay. See, for reducer, it should require all the mapper output is the input for reducer, correct?
Yes.
But one mapper failed, it didn't generate output.
No.
Then
Then it will launch another application master will launch
okay.
another.
So that is the reason. Okay, what help is being every task will have multiple attempts. Okay. So here this is the attempt ID. Okay. How attempt IDs will be created? Attempt IDs will be created. Attempt IDs will be created like this. Wherever you have task will be replaced by attempt. Okay. So the remaining everything will come as this. Okay. At the end, you will get underscore 0. This is underscore 0. Okay. So by looking at this one, what you can say? This is the M00. First you need to understand M00. First mapper, 0th first attempt. Correct or not? Huh? So like this, okay. Every mapper, every reducer will have 4 attempts max. Including first attempt, okay. You will have 4 attempts. Okay. So every map task, every reduce task will have maximum 4 attempts. Okay. So now, think like this, guys. Okay, let's say, so now this is the application is submitted. It has 2 map tasks. This is the task 1. This is task 2. Okay. So task 1, attempt 1 started. Okay. Due to some reason, it is failed. Okay. If it is failed, then what will happen? Okay. Immediately, application master will understand that first task, first attempt is failed. So let me give one more attempt. So it will start the same task. Second attempt it will start. It means it is repeating the same task once again in a different language. Understood? Okay. So now, if this is also failed, what will happen? It will try for third attempt. Okay. It will try for third attempt. Okay. Let's say this is successful. This is succeeded. Okay. This is succeeded. Okay. Now what to do? Okay. It means this is fine. Okay. See, third attempt is successful. Okay, like how every student will get chances, right? If March failed, you will have September. Yes or no?
Sir, is there any thumb rule for failed? Like if it is failed in S3N1, it will go for S3N2, something like that.
Just 1 second. Yeah, sorry guys, you're asking something for something.
Sir, is there any thumb rule that if failed in S3N1, it will launch mapper
Of
1
course, yes,
in
yes,
another?
yes, yes, yes.
Okay.
So let's say, okay, it launched, okay, it launched this container. The attempt one has launched on S3N1. Okay, if it is failed, S3N1 failed. Okay, it will try on S3, maybe S3N2. Next time it will try. The second copy of this block is available. Here also it is failed. Okay, it will try on S3N3. Okay, let's say this is successful, succeeded. Then it will stop it here. Will it try it after successful? Okay, will it try for fourth attempt also?
No, no.
No. Okay. Okay. Now, okay, you see this one. Okay. So this is succeeded in the first attempt itself. Then will it try for second, third, fourth attempts? Sir, okay. See, in the first attempt itself, your exam is clear. You pass the exam, sir. Okay, will you try September also?
No,
Will you
it will
write
not.
September? No, right?
No, sir.
So this think that okay, this is March attempt, this is September attempt. Okay. If March attempt is successful, okay, why you write okay again like exam in September? If March failed, then only you will go for September. If that September also failed, okay, then you will go to next March. Understand? Okay, and this is also reduced also completed. Okay, so now okay, this is completed in S3 and 4. Okay, yes, okay, it will not try for attempts, but okay, what I'm trying to say here, every task will have max of 4 attempts. Okay, now the question is that okay, what will happen okay if okay third attempt also failed, fourth attempt also failed? It means okay, so there is a task. Okay, all 4 chances, okay, it lost all its 4 chances. Then what will happen? Then entire job will be marked as failed. When I will say entire job is failed, even though okay, see, I have all the other tasks successful, but if this task is any one task is failed, okay, all 4 times, okay, then I will mark entire job as a failed job.
Sir,
Because
this will
okay,
manage application manager this entire
yes,
task.
yes, okay. So which attempt, okay, so where to start, everything will be managed by application master.
Okay.
Understand?
Sir, default retries are 4, right, sir?
Default retrace are 4. Okay, but okay, if you want to change it, okay, so again, where you can see this default retrace, user local Hadoop, okay, etc Hadoop, okay, so map.site XML. Okay, so here you can see what are the how many retrace okay you want to do for mapper. How many retrace? Okay, how many maximum attempts for mapper? 4. Okay, reducer attempts 4. It means okay for mapper and reducer, okay, both we have 4 attempts. Okay, but if I change it to 5, what will happen? Then okay, every task will be tried for max of 5 times. Understood? It's purely based on the configuration file, right? If you want to give for each task, if you want to give maximum five attempts, you change the property in the configuration site XML. Okay, it's okay. You see one here. Okay.
Sir, one query. When we are
One
submitting
second.
job, whatever logs we are seeing in console, that will be stored somewhere, yes or not?
For 1 second. 1 second.
what we are doing, sir, here?
I'll tell you, sir. Okay. Okay. If any now you can see. Okay. Now any property you see as final. Okay. Suppose okay now max attempt equal to 4, right? Okay. If the final equal to true, then okay you cannot change in the command line this one. Suppose okay I have any property, so now reducer memory equal to 1024. Okay, 1024. Can I change this value in the command line? I can put -d and I can change this number, right? But when I say final, okay, you cannot change this in the command line also. Sir, okay, here, what is the size of a reducer? 1024. But okay, I don't want I don't, okay, this is as per configuration file. But okay, for my job, okay, I want a bigger reducer. Okay, so what I'm doing, okay, I'm using like this, okay, so the same property I'm passing here, okay, so reduce dot memory equal to, okay, what is this one? So map reducer reduce dot memory dot mb, okay, the same property I'm giving my reduce dot memory dot mb, okay, I'm giving 4096, okay. So here I'm overriding this value. It means, okay, so in this scenario, your mapper, okay, sorry, your job will take reducers as of 4 GB, okay. But if you give any value as final, okay, this cannot be. Even if you give different value in the command line, it will not take. It will take this one. Final means if it's a fixed value, you cannot change in the command line. Got it? Huh?
So you mean to say we cannot even decrease that value? That's a fixed value.
Sir, let us take this scenario, sir. Okay. Normally, what is the block size as per this one? Block size here.
128.
Here 128 MB. Okay. If I want to write my data into 100 MB pieces, can I write it?
We can change the configuration.
Any configuration means again restart, everything will be there, right? But okay, see, I don't want to follow that 128 rule for my file. Okay, then what I'm doing, I'm passing this property here. Okay, 100 MB. Then what will happen? My file, okay, so whatever the file I'm writing, okay, so -put so sample 6.txt, okay, into project underscore BLR. If I execute this command, what will happen? My file will be divided into, suppose okay, if samples.txt is 300 MB, so how it will be divided? 100 MB, 100 MB, 100 MB. It means, okay, I am telling in the command line, I don't want, okay, that 128 MB block size there, okay, which you mentioned in the configuration file. I want to be as per my number. Okay. Got it? If you give in the command line, it will take this number. RK will take 100 MB now, RK 128 MB block size. RK you are saying, okay, I want the replication equal to 5. Okay, DFS dot -d, DFS dot replication equal to. Okay, now tell me, will it copy 3 times or 2 times?
If it is final, then it will not take. If it is not final, then it will take.
Exactly, sir. Okay. So normally, if it is not final, if I say final true, if I don't use the final true, then okay, you can change it in your configuration. But if I say final true, then okay, even if you put it like okay, so 3, or if you put it like 4, it will take 3 only. If I say final equal to 2, okay, it cannot be changed in the command line. Got it?
So by default, the final is equal to true is there, sir, in real time?
No, by default, final equal to false.
Okay.
Understood?
Okay, sir, got it.
Yeah. Okay. So a few things, okay, you cannot override. If you say final equal to true. Even if you override also, it will not take your value, it will take the value which is there in the configuration file because it is final equal to true there. Okay. So now every task, okay, see, every job will be divided into map, okay, will have multiple tasks. So multiple map tasks and multiple reducer tasks, okay, and each task ID will be created like this, and each task ID will have, okay, max of 4 attempts. Okay, if first attempt is successful, then okay, it will not try for second attempt. If first it is failed, it will try for second. If second also failed, it will try for third. If third also failed, it will try for fourth. Okay, so like this, max of 4. If the 4 is reached, okay, so if all 4 are failed for this task 1, if any task is failed for 4 times, okay, then entire job will be failed. Understood? Understood, or any questions? Okay, so that's what I'm telling. Task IDs are found by task underscore, okay, replacing this application with the task, and okay, adding the suffix of -m. Okay, -m002 means this is the third map or task of the application. Guys, okay, in real time, sometimes you know what they will do, they will tell, okay, hey, this is the task I failed. They will give this number. They will not do this number. Okay. Okay. When you give this number, what you will do? How to check the application number now?
We can make it, yes, sir. Application underscore, then yeah.
Application underscore, first two things. That's it. Okay. This is your application ID. You attempt, okay, change it to application, and okay, this the rest of the number is like, okay, this is your job ID. Correct? Correct or not? Okay. So task IDs may be executed more than once due to task failures or speculative execution. Okay, so any task can be executed more than once. Okay, it may be because of the speculative execution, or it may be failures. What is speculative execution? I'll cover in the next slides. Okay. So to identify different instances of the task execution, okay, each task will be given with the different attempt IDs. Okay, so attempt underscore, okay, task ID underscore attempt number. Okay, so all these things are, okay, see, application IDs are given by resource manager, but task IDs are given by application master. Attempt IDs are given by application master. Okay, understand? Okay, so the next one is job configuration and history. Okay, so guys, okay, we discussed about two things. Okay, so discussed about two things. One is job configuration XML and job history JSON. Okay. So job configuration refers to the properties you used in the job submission or execution and stored in XML file. What is job configuration? Job configuration is nothing but the properties you used in the job submission or execution. Okay, so all these job properties are stored in XML file. Okay, so and job history refers. Okay, job history means refers to the events for a completed map reduce job. Okay, so job history includes, okay, job ID, task ID, and attempt IDs. All of which are stored in a JSON file format. Okay, so now, okay, when application master is trying, okay, so task 1, attempt 1, it will write in the history file saying that, okay, I'm trying task 1 on attempt 1 on history and 1, it is failed. So I'm trying, okay, same task, first task attempt 1, attempt 2 on history and 2, same task attempt 3 on history and 3, same task attempt 4 on history and 4. So like this, okay, it will maintain history of each and every task in the job history JSON file. Okay, so these files are created and stored in HDFS by application master. Who will create these files? Okay, who will create these files? These files are created by application master and stored into HDFS. Okay, so and again, okay, these two files will be created whether job is successfully completed or failed also. The job is failed also, these files will be there. If job is successful also, these files will be there. Okay, and these will provide a different, okay, I mean useful information actually. Okay, and okay, the STFS path to store. Okay, what is this STFS path to store? Okay, STFS path to store these files can be set by using this job history and directory. Okay, so what is the path? Okay, this is the path actually. Whatever the property you set for the directory, in that path, okay, these files, XML files will be created, and but default path is this one. So default path is this one. Okay, so here you can see configuration. This is the default path where you will see config XML as well as job history JSON, both the files for any job. Okay. Okay, just try to understand. Okay, I told okay, we run 3 lakh jobs in a day. Okay, if I run 3 lakh jobs in a day, how many config XMLs will be created in a day? 3 lakh. Each job will have one config XML. Okay, how many job history JSON files will be created in a day? Huh?
3 lakhs.
3 lakh above.
3 lakhs if all are successful.
Yeah, okay. So for every job, you'll have one config XML, one job history JSON. Okay. So if you run 3 lakhs jobs, you'll have 3 lakhs job config XMLs, 3 lakhs job history JSONs. Okay. And okay, so like this, okay. If I keep on storing these config XMLs, job history JSON files on HDFS, then what will happen? One fine day, your HDFS will be full with these files itself. Okay, that is the reason we have some retention. Okay, so by default the retention value is 1 week. It means okay, after 1 week these files will be deleted automatically. Understood? So today's 3 lakhs files will be deleted after 1 week automatically. You don't need to do anything. Understand? That is the retention value which you are mentioning in the configuration. Okay. So here, okay, the history of the job configuration properties or history of the job, okay, can be seen through web UI of your history server, which is linked to your resource manager. Okay. If you want to see history of any job, you can see it here. Okay, so this is the job ID, and if you want to see the history of this job ID, click on this history. Okay, then it will be showing the history of this job, what time it started, what time ended, how many mappers are there in this job, how many reducers are there, okay, how many application masters are there, all those things will be shown here. Understood? Or any questions?
Sir, one general question. When we are submitting a jar, that time some logs are coming in our command line. Yes, those logs where these logs are getting stored exactly in.
No. Okay, at this moment, okay, I discussed about RM files and application master files. Yes or no? What are the different files maintained by RM? What are the different files maintained by RM?
Application state store.
Application, yeah.
Application state store and cluster state store.
Yes, sir.
Okay, this is application state store. Okay, so this is application state store. Okay, applications contain information about all the applications. Cluster state store means information about all the nodes. How many node managers we have? This application.
Yes, sir.
Okay, so these two files are managed by resource manager. Okay, and configuration XML job history files are managed by application master. Okay, yeah.
Okay, sir. I got it.
Yeah. Other things that I'll explain the next slides. Okay. The next one is counters. What is counter here? What are counters here? Okay. Normally counters are so statistics about your job. What do you mean of statistics, guys? What do you mean of statistics? Okay. Let us take this scenario. Okay. Let's say there is a job. This is the job. Okay. So this job is having so if you see the click on history, this job is having 0 reducers, right? Okay, so I'll take other job. Okay, this is the job. So this is having how many reducers? This is having how many reducers we have? We have here
3 reducers.
3 reducers. Okay. Now click on these 3 reducers. Okay. Now click on any reducer, first reducer. Okay, let's say this reducer got failed with out of memory exception case. Due to some reason, this reducer got failed out of memory exception. Okay. What do you mean of out of memory exception? What do you mean of
size, maybe heap size is not sufficient for the file.
Sir, no. It means out of memory you will get when sum of input plus logic is not fitting inside
output.
Input and logic is not fitting inside.
Container.
I mean, inside the container. Correct or not? Okay.
Yes.
So that is okay. In such scenarios, okay, heap size error will come. Okay. Now, how do you know? Okay, how much input? What is the size of input this task is processing? You got my point? How do you know what is the size of input this is processing? Click on this one. Here there is something called counters. Click on counters. This will tell you, okay, how much data this is, okay, this is processing. Okay, how much data this is processing? Okay, this is processing 37 bytes. Understood, sir? Okay, this is processing 37 bytes. This is the input data. This is the input data. Okay, but okay, what is the output it has written? What is the, okay, this is a reducer 1, right? Okay, so reducer 1. With output 7, 3 reducers. What is the size of reducer 1 guys? How much output it generated? Huh?
19 bytes.
19 bytes. 19 bytes. Okay. Is it showing here? In the same way, let us go to second reducer. Second reducer, click on counters. So what is the input for second reducer? 16 bytes. What is the output it generated? 6 bytes. 6 bytes. Huh? 6 bytes or not? Okay. And what is the third reducer? Reducer. Okay. So this is the third reducer. Okay. Click on counters. For this input is this much. Okay. Output is this much. 20 bytes. Is it the 20 bytes? Huh? Yes or no? Got it, sir? Okay. And now, okay. So now here you need to now click on this one. Click on this one. Click on counters. So counters are not only talking about okay this one. Okay. So this is the input size and this is the output size. Okay. But here okay, it is telling that okay, how many records it is processing. How many records it is processing. Okay. So how many records it is processing? Here okay, you can see input records. How many total input records it is processing? It is processing 3 records. Understood? Okay. Understood. How many records it is processing? Input records are 3. Okay. And now, how much time it is taking? CPU time it is taking. Why 60 milliseconds it has taken to complete this task? Okay. How much RAM it is used? It is used, okay, this much RAM. Okay. Around 180 MB RAM it has taken. Even though you say, okay, use 4 GB RAM here for reducer, but it has taken only 187 MB. Within 197 MB, it completed the reducer task. Understood? Understood, guys? So normally, okay, you look at okay, the input size, okay, output size, okay, number of records, okay, what is the time spent for CPU, what is the time spent for RAM, okay, how much are the major things what you look into counters. Counters are very, very helpful to talk about the numbers. Understood? To talk about numbers. Okay. So tomorrow, if any task is failed due to out of memory exception, okay, it is very easy to come and check this one. Or if somebody says that okay, my job is running slowly, okay, so now you can come and check here. Okay, there may be like okay, so if you give 10 reducers, okay, 9 reducers are processing very less number of records, and okay, 1 reducer is processing okay more records. In this scenario also. Okay. Even though there are 10 people, one person is working full and other people are sitting ideally. Other reducers are sitting ideally are doing very less work. Okay. So you can understand that also here. So normally counters are very, very helpful, useful channel for counters are very, very useful channel for collecting the job statistics. Okay. So counters are not only for reducers, guys. Counters will be there for even mappers also. Okay. Just click on mappers. Okay. So you have only one mapper. Okay, click on that mapper and click on counters. This will tell you. So what is the input? Okay, input is 146 bytes. Okay, input is 146 bytes. Okay, the output is okay. No, input is 44 bytes, not 144 bytes. Okay, so this is the input actually. 44 bytes is the mapper input. Okay, and how many records we have? Okay, map output records. How many records we have in that? 10 records. Yes or no? See, input size is this much, but how many records we have? Different records, 10 records. So 10 records means these are the ones 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 records. This is the mapper output. It is clearly telling that okay, how many output records I'm generating? 10 records it is generating. Okay, understand? 10 records, but in that okay, unique records are only 7 records. Unique records. Understood? Okay, so these counters are very helpful in performance tuning. Very helpful in the performance tuning. Okay, so you need to understand. Okay, so normally you know what they will do in real time. Okay, so they will capture this counters information and store into Kibana or Elasticsearch normally. Elasticsearch. You don't know what is Elasticsearch at this moment. Okay, so that we will see in the later stages. Okay, there is a tool called Elasticsearch. So normally what they do, because they will copy these counters, okay, files, okay, from SDFS to Elasticsearch, and okay, and they will start generating the reports like, okay, who is the person submitted more jobs today? Okay, so let's say I have 10 people in the team. Okay, out of 10 people, who submitted more jobs today? Okay, in last 1 month, who submitted more jobs? Okay, so whose jobs got failed more? Okay, let's say maybe so there are 100 jobs submitted by 3 people, but okay, one person submitted 20 jobs. That okay, 20 jobs, 15 jobs are failed. It means he doesn't know how to write the program. Yes, sir. 15 jobs are failed out of 20 jobs means what does it mean? Okay, he doesn't know how to write the programs. Okay, okay, what is the top big jobs? If you want to know which is the top job, okay, with more number of mappers and more number of reducers, you can see top jobs, top 10 jobs. Okay, okay, least jobs. Okay, least 10 jobs. Okay, like this. Okay, these kind of reports they generate using these counters. Understood? Okay, so but all these counters information is stored in the job history JSON file, guys. That is very important. So all these job history JSON files are stored in the job history JSON file. Understood? Any questions? So counters are very helpful. Okay, it will give you a lot of information like, okay, what is the input data? What is your input data? What is your output data? Okay, and okay, how many records you are processing? Okay, what is the input records? What is the output records? Okay, so all this information will be maintained in the counters part actually. So counters are like numbers about your job. Understood? Okay, so counters are very useful channel to get the statistics about your job. Useful for problem diagnostic as well as quality control. Okay, so quality control means okay, there may be some people. Okay, so see here, guys. Okay, what is the size of reducer I have given? 4 GB I have given. Okay? But if you see actually, how much time it is? How much size it is taking? Reducer is taking only 180. Okay, nearly 200 MB. So it means okay, this job can run with 200 MB container also. But how much MB, how much GB I'm taking?
4 GB.
4 GB, which is waste, right?
Yes, sir.
Yes or no?
Yes.
Okay, so quality control. Can I use this for quality control also? Normally, what developers will do? So developer run a job first. Okay, so they will go with some okay assumptions actually. So this should be the map of size. This should be the reducer like this. Okay, they'll go with some assumptions. Okay, but once they run this job, they'll come and see these counters. Okay, counters will give you exact information like okay, what is the good number for this one? So in here it is saying that okay, maximum memory it took is okay. Even though you give 4 GB, it took only 200 MB. Okay, like this. Okay, they will check okay for each and every reducer 200 MB here. Okay, And second reducer, okay, how much? This also nearly 200 MB, okay. So and third reducer, okay, so counters, okay, this also nearly 200 MB. It means, okay, so if I give 200 MB or 250 MB, okay, you need to take the biggest number actually, okay. So if you give around 200 MB or 250 MB container, that is more than enough to complete this job. We don't require 4 GB container. Understood? Okay. So these controls are very helpful for the quality control. And you can track all these counters parted from the web UI of Resource Manager. And these counters will have different type of counters. Okay. So if you see here, file system counters, map reduce counters, shuffle counters, like this. Okay. Any questions, guys, on the counter part?
Sir, in previous slide, I have one doubt, sir.
Yes, sir.
So when you are submitting the job, you're creating the file in local file system like sample.txt.
Okay.
And then you're copying that file from local file system to
HDFS. Yes.
By using put command. So
okay.
Instead of doing that, can't we create the file directly in HDFS?
No, sir. No.
You cannot create a file in HDFS.
No, directly no.
In real case also, same thing they will do.
Mostly, yeah.
So from local file system,
you need to create a file and you need to copy it in the HDFS.
Okay, sir. Thank you.
Yeah. Okay. So we'll stop it here, guys. Okay, so we'll continue tomorrow.
Sir, how hash key algorithm works? Can you please explain an example?
Sir, okay, hash key algorithm normally. Okay, so if you give okay, so if you give multiple inputs here, okay, okay, you need to tell, okay, these are my inputs and these are my numbers. Okay, so suppose okay, you give 10 people and okay, give 3 numbers, then what will happen? These 10 people will be given to will be assigned with these 3 numbers, any one number. Understood? So I have 10 people. Okay, for each people, I need to make 3 groups.
Okay.
Okay, so group 1, group 2, group 3. Okay, so it will decide who should come under group 1, who should come under group 2, who should come in group 3.
Okay.
Okay, that's how it works.
Okay.
Yeah.
Sir, is there any real-time example for this, sir, hash key?
Sir, this is the real-time example. You have some people, okay, you want to divide them into 3 groups. How will you divide? Or you want to divide 4 groups? Okay. Just go through internet once. Like hash key algorithm is very I mean, it's an old one. Okay, you can understand it very easily. They'll explain clearly. Okay.
Okay, sir.
Yeah. Thank you, guys, and see you all tomorrow. Thank you.
Thank you.